It's when you're ready. That's the reason why I'm like, I'm not pushing you. I want you to be ready. If you don't feel like you're ready, then fine.
Do I already have the answer?
Yeah. All right, class.
Yes.
Thank you. Did you lose it?
I like keep everything in.
You like to lose it, lose it. You like to?
I do have a folder. It's just everything's in my folder.
Yeah, I don't want.
I need a folder just for certain
I'll buy you one.
No, seriously. Do you need another one?
Yes.
Okay.
I know I have these.
All right. Okay, implicit differentiation. Like I said, I was talking about, I prefer the Leibniz when we're doing this because that's the one that actually makes a little bit better sense and it's easier to identify. All right. Find dy dx of x times y minus 4 equals 0. Did you really just start crying? There's no crying in math! There's no crying in math!
As soon as I see two variables, they just break down.
Okay, so we're doing of x times y minus 4 equals 0. Okay, and there's a reason why I said it's x times y, right? Okay, so we're going to take the derivative of each item individually. Because this over here is x times y, that's going to be what rule? Very good, that's product rule. That's product rule, okay? So I'm going to use that information. And I'm going to do the notation like I should. So x, right? Since this is going to be product rule, it's going to be basically x, and then the derivative of that would be, what's the derivative of x? 1. Now, I took a derivative of x, didn't I? So instead of calling this u prime, okay, when we actually do this, or x prime, or whatever it is, this is going to be dy dx. The next one is going to be my y's. So it's y, and the derivative is going to be, what's the derivative of y? 1, and this is d dy. Because I'm taking the derivative in terms of y this time. Now, if you notice over here, isn't my problem saying dy dx? That's what I'm finding in the first place, right? And this one right here, when I did dx, isn't that the same as dy dx? This and this are the same. So because these two things are the same, I don't have to rewrite that one every time. Because that's my initial, what I am looking for in the first place. This, I don't have to write it. Because it says I'm taking the derivative of function y in terms of x. So when I take the derivative of function y in terms of x, I don't need to restate that. So I don't need to rewrite this. I don't need to rewrite that because it already says that's what I'm supposed to be doing. But when I actually do take something, a derivative of something that is not this, I state it. Or another word, I would just call that one 1 times y prime. That'd be the regular notation. Does that make sense or no? Did I just say too many words? Is that what it is?
Does it matter if it's 1 or is it any number?
This, why is it 1?
But if
Yeah, it'd be that number, right? It's just whatever it is. We're just dealing with the most basic right now. Okay, so let's do the product rule. You ready? So product rule here says f prime. What is this one right here? What's the derivative of x? 1. Do I need to put dy dx? No. Good. 1 times, so it's f prime g. In this case, what is my g? Y. Because I asked. Parating. Anyway, what's the symbol that goes next if it's product rule? Product rule is plus. Next one's going to be g prime f. G prime is going to be the derivative of y, which is 1 times dy dx. No, I'm sorry, not dy dx, dy. There we go, dy. Because I'm taking the derivative of something that is not the x. Okay. And now it's times f, all right? So this is g primes times f, and my f in this case is x. Christian, you okay? Juju? Okay, so you ready? You ready, Juju? I'm gonna have you do this next part. You ready? Okay. So we're done with the product rule, right? Now we come over here to this minus 4. What's the derivative? 0, because it's constant, right? Okay. So that's 0, and then it's equal sign. What's the derivative of 0? 0. Does that make sense so far? No? What part don't you like?
Why do we write d over dy instead of just x?
See this right here? So in my thing, this was my g. Not my g, my f. This was my f, and this is my g, right?
Right.
Okay, f. Okay, so f prime was 1. G prime is 1 times dy dx. Does that make it a little bit easier?
Yeah.
Okay. All right, so let's go ahead and put those together. So I'm going to take away what I have, and so now I'm going to isolate a little bit. So this is going to turn into y plus 1 times x is x d y equals 0. Make sense or no? So far? Are you okay, Christian? You got me worried here.
You just combine them.
Yeah, 1 times y, right? 1 times x, and it's still times the d dy. Sure?
Yeah. Got it. I get it. We're combining.
Okay.
Yeah.
All right, so now I'm going to try and isolate to get the d dy by itself. Okay, so this is going to turn into subtract y, 1 times x, 1 times d dy. 1 times x is 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 1 times d dy. 1 times So I get x d and then divide by x. So there's my derivative. Hmm? Why is it respect to y? Trying to understand what you're saying, but yeah. So in regular notation, what would that d dy look like? Would that be just y prime? What do these guys say? Oh, they just use d dx instead? Oh, so then I messed up. I get the same answer. Yeah, I typoed. My answer's correct. This right here is correct. I typoed, so it should be this x instead.
Oh, thank you. Okay, that was what was confusing me the whole time. I was so, why was that why?
I'm sorry. There you go. Sorry.
That makes more sense.
So I get the derivative here. This would be the same as saying my y prime, right? So my y prime should be equal to that. So now the next part of the question says, let's go back, solve for y, and then take the derivative. So that would be x times y minus 4 equals 0. So let's get y by itself. So I'm going to start by adding 4 to both sides. X times y equals 4. Divide by x. Y equals 4 over x.
What are we doing? Was this for B or C?
B.
B.
It said solve for y. Solve for y and then differentiate. Then take the derivative. Okay? So now, a little bit of algebra. I got y by itself. So if I take the derivative, it's going to look like this. Y prime. Actually, before I do the prime, let's rewrite it. So what's going to happen here? I get 4 over times x to the negative 1, right? Yes? Okay. And then now derivative, so y prime is equal to negative 4 x to the negative 2. Rewrite it. Y prime is equal to negative 4 over x squared. Now we're comparing. So two things I'm gonna compare. I have, this one was and this one is y prime, same thing. Was it negative y over x? The difference right now is that my top one has a y in it again, doesn't it? It does, doesn't it? The bottom one doesn't have any y's in it. Can we substitute? Do we know what y is equal to? Y should be equal to what? Y is equal to 4 over x, isn't it? So if that's what my original problem says, that y is equal to 4 over x, can I substitute y back in? Yes, that's going to be a little bit of algebra here. So let's try that. So we're going to say that negative y, but y is being replaced with 4 over x divided by x. And all fractions could be written as, or all whole numbers could be written as over 1, right? I'm hoping that this is going to help this out. So, do I have a fraction over fraction? Whenever you see a fraction over fraction, you multiply by the reciprocal of the bottom. So you take the bottom number and flip it over. So that's going to turn into my negative 4 over x times the reciprocal, which is 1 over x, which gives me my negative 4 over x squared. Yes, no, maybe? So, are these going to be equal? Yes, they are the same. It just depends on how it's written, and if you're not a moron like me and have a typo for this whole thing, and say ddx instead, or ddy instead of ddx, so it should have been dy dx for the whole thing because I'm taking the derivative in terms of when I don't have the x. So, I apologize for being stupid. I will give you guys free coffee today. Okay, good. Alright, with me being a little bit less stupid, power rule, same thing. Okay, now, here is the rules for this. And the notation says it's going to look like this. Okay, for this is when I'm actually going to have more than one variable. I'm going to have both the x and the y when I'm plugging these in to implicit. Okay, alright, so, and yeah. So, let's go through this. So this is what most of our problems are going to look like. That first one we started off with the product rule, right? This one doesn't have a product rule. Now, take the derivative of 3x squared, because right now I'm taking of this, right? So if I take the derivative of 3x squared, that is 6x, very good. Okay, it's good. It's following along with what I said. Now we're going to take the derivative of the 4y squared, which is going to give me, take the derivative of it, it's going to be 8 y, but because I'm taking the derivative of something that's not there, it's not what I said to do in the first place, I'm gonna add that. Okay, and I am not gonna typo this one again, d, there you go. Equals derivative 2x is 2. And now for the next part, it's algebra. I just want to get the dy dx by itself. Because that's basically my y prime that's saying, hey, the derivative is all this. So I'm going to go ahead and take that one, and I'm going to move everything else to the right hand side. So subtract 6x. So I get 8y dy dx equals 2 minus 6x. And my dy dx is being multiplied by 8y. So to undo that multiplication, I need to divide. So I get dy dx is equal to 2 minus 6x divided by 8y. And why? Because I said so. Alright, you don't want to get too crazy into this. So yes, they are kind of weird problems, but I still want to give you guys time to work on this, to try out some of these problems already. So I'm going to stop here for today, and then I'm going to come around and help you guys with any of your work. So make sure you all like, share, and subscribe. Hit that notification button, support my channel.